Alrighty, welcome to my hopefully gentle introduction to Git. As usual, if you have questions, please just unmute and share them and jump in. If you want to, you can use the participants panel and pop up an icon there, whatever you're comfortable with. Git is often scary seeming because it does a schmillion things, but today we're just going to cover what exactly is it, some simple workflows that you can do, how not to get confused as you work with it, a few different clients that you might want to look into if the command line isn't for you, and just a few more examples of using Git to do some various things. And so you kind of have an idea in your head of what you can do if you choose to learn more than just sort of the simple operations. So to start, what actually is Git? It's a distributed version control system. The way to think of it is, I think, as a backup system that keeps every version that you choose in a long chain so that as you're making changes, it contains all versions of the files that you've put into it. So you can go back to the state of a given file on a certain day or the state of your whole directory. We'll call it a repository today, your repo. You can see all your messages that you've left with those changes as well. And you can compare different versions very easily. So that makes it so it's easy to track changes by, even if it's just you, it can be handy to track changes with Git as sort of chunks of logical work. I use it even on projects that I'm only working by myself on, because then I can see, oh yeah, last week I did this commit. Let me see, what did I change? And it's also easy to prototype off in branches, and you can work offline. But how many of these things are actually relevant to you in your day-to-day work at the center? Not as many. You can collaborate using different merge workflows in Git and all this fancy stuff, but what are you really going to use Git for? I recommend it because it's really quick and easy to do a history and sort of a backup restore without having to wait for help at BI on the study drive. If you have some scripts you're working on, you can put them in Git and very easily get back and be like, oh, I shouldn't have done that. You can go back in time very easily. It's also very good if you're working on something with more than one person. It's fantastic for that. Right now, if you edit files on the study drive and someone else is also editing those files without an intermediate program like Git, you're going to be the last person to save wins, which isn't awesome. Somebody could lose their work. Git would help avoid that. And this one, I had a hard time phrasing it in the slide. Let's ignore what I said there. Basically, I want you to think about the common pattern at the center of commenting out code when you're not sure you want it anymore. What ends up happening is we get these scripts that have lots of commented chunks of code, sometimes right next to each other, where some has been commented out 5 years ago and some was commented out a year ago. And it's unclear why they're commented out, and it's all very confusing. With Git, I would recommend just deleting code because you've got it in Git still, and then using your comment log, your commit log in Git to make notes of why you're removing certain things, which will make it a lot more obvious than the trying to do it all in a single file. Is Git complicated? Yes. In total, Git can do so many things. I don't even understand it all. It's crazy. But also no, if you use just a simple subset of Git, it can be quite useful and pretty easy to remember what's going on. And so today we're going to cover that small subset of simple behavior. So if you've got your terminal up or your Git bash open, we're going to make a new Git repository right now. And I'm going to put it all on one screen just so you can see that it's not that many things, and then we're going to go over them one by one. So we're going to introduce some basic terms and then get started. I already mentioned this. We call it a repo. It's just a set of files. It's like a folder full of files, but Git has some additional tracking information that lives in a secret .git directory, and everything else is the work tree, which is just your normal files. So in your terminal, I would like you to make a repository. you can do this anywhere in your home directory or wherever. I usually keep a directory called Git in my home directory and keep all my Git repositories there, but it's totally up to you. For right now, we're just going to make a directory called Git test. So I'm going to go mkdir git test. I'm going to cd whoop into git test, and then we're going to say git init. And you'll see it says initialized empty Git repository. And if you ls, there's nothing in there, except if you ls -al, you see that there is that hidden .git directory. Is anyone following along who is lost right now? Okay, cool. That initial step isn't very exciting. Now, let's talk about the stage. The stage is the concept of Git in what changes to the repository are pending. A lot of times I see it in the Git documentation called the index, but I feel like the stage is clearer because you're staging changes. They're, I think, equivalent words. So let's stage some files. You can either open a text editor and just make a new file. I'm going to touch new file to just make a blank file. Once you've got a new file and you do git status, you will see some information. It will tell you on branch master, no commits yet, and it will tell you there's an untracked file and that you can use git add to track that file. And so we're going to do that. We're going to say git add new file. Doesn't do anything. It just puts you back at the prompt. But if you type git status again, you will see that instead of saying it's untracked, it will say there's this change that's about to be committed. We've got a new file. And then we're going to talk about clean and dirty real quick. If you do git status in a directory and you see nothing, that means everything is clean. Everything you've done is stored in Git and you haven't made any changes since then. If you change files, you make new files, you delete files, all of those will create a dirty tree. And when you do git status, Git will warn you about them in red usually. And there are three key places that we're talking about. We've got our working directory, which is the actual files that you can easily see. Then you've got the idea of the Git stage. When you add files, when you say git add a file, that goes into your stage. And then you've got the final head of your branch, which is the hidden sort of log of all the different changes you've made over time. The head is the most recent one of those. And it's usually the current branch is usually main or master. You don't even really need to worry about that current branch thing unless you're doing branches though. So we're going to ignore that for now. If I say, I'm going to go back to my slides for a second. So we did add already. It just puts changes from your working directory into the stage. If you're ever unclear and you just want to add everything in your directory, you don't have to name them all. You can just say git add dot, which adds the current directory and all changes in it. And then there's checkout. That would be if you want to say you've stored a file and you've made changes locally, but you don't like those changes and you want to go back, you say checkout to get that file from the original version.
Hey, Dan.
Go for it.
Just a quick question. So on that last step where you said git.add, and you can just add the whole directory that you're in, would that be the way to just add all of your scripts, like go to the directory where they are and then do that command and it would just take everything, or?
Well, keep in mind that a Git repository is linked to a particular directory and you can only do operations in that directory. So if you have a directory of scripts already, you can init inside that directory and then add that directory and it will add all of them right there. But if they're like in different directories, then you probably want an individual repository for each, or you should talk to me because there are fancier things we could do. For right now, we're just going to deal with the simple case of it's a repository with, it's just a directory that has a pile of scripts in it. For that case, you could say git init, and then after that's done, you would say git add dot, and it would add all those files. So if I make some more files, it'll be like, oh, those are new. And if I add dot, it will say, now everything is ready to be committed. So let's talk about committing. Committing is when you take the stage and you say, I'm sure this is what I want to do, because there are ways in Git to unstage things and say, oh, whoops, I didn't mean to make that change, or I want to change that file again and stage changes on top of it. Once you've got things ready, then you just commit. And to do that, let's try it. We're going to do git commit -m, which lets you pass a message. If you don't do this and you just type git commit, it will open up an editor to let you edit the message, which may be weird depending on how your system is configured. We can deal with that outside of this class. But for right now, just type git commit -m and some kind of message. And once you do that, you'll see it's got a little bit of information about what files were changed, how many lines were inserted and deleted, and if there are new files, it will tell you what permissions they were stored under. And if I do git status now, you'll see it says everything's fine. The working tree is clean, but as soon as I start editing files, if I go into one of these files and make changes, now when I do git status, I will see that, oh, changes not staged for commit. This new 2 file has changes. And then I could do, again, git commit. And the -a is a secret thing that adds all the files that are already in Git. And I could say, making changes. And so on. I could then go into new 2 and say, add content. And then there's a command called Git Diff, which lets you see what's actually different. So you'll see here in green, it's telling me I've added 2 lines. And in a complicated change, diff can be very helpful so that you can see the results of your changes. So let's actually look at an existing Git repository. Let's go back up out of our directory that we're in. And we're going to clone. I'm going to cheat and copy and paste this real quick. I will paste this line into the chat as well. Just a second. Oops, I did that wrong. I'll paste this into the chat quick. So this is some software that Nate wrote that is on the CHM GitHub. When you clone things over the GitHub's HTTPS, you get a read-only copy. Well, you can write to it locally, but you can't ruin anything. So don't worry about that. You can't send changes easily back. So copy and paste that git clone line in your terminal. And then once that's done, it shouldn't take too long. This isn't a huge repository, and Git is super efficient about network use. I want you to go cd bioread. You'll notice that by default, when you clone a repository, it uses the last bit of the URL as the name. So in this case, it did bioread. If you want to name something else, you can say git clone a URL space your name for it. So you could give something a different name if you wanted, but for right now, I think bioread is fine. So now let's look a little bit at this repository because it's got some more fancy things happening. It's got branches. And so the way to think of this is kind of hard to conceptualize if you haven't been kind of down in the programming nerd land, and you don't necessarily need to understand it right now. I'm just throwing it out as an option. You can have your main branch, and then you can make modifications to both that branch and another branch, and Git will hold them both in memory at the same time and let you switch between those 2 versions. So you could do a prototyping branch where you're working on something else. And how you would see that is by typing git branch. So if you're in bioread and you type git branch, you'll just see main, which is normal. But if you type a longer command that I just have a shortcut for, you'll see that there's actually some cases where people did some work on a secondary branch and then merged it in to the main branch. So this is all funky stuff. You don't need to know exactly how this works. I'm just putting it out there as a thing Git can do right now. The other thing Git can do that's pretty handy is you can tag a specific version. When you're at a version, or even going back in time, you can tag a previous version if you decide. You can just say, to tag the current version, the current head, you can say git tag and then a version number. Now, the reason that's kind of handy is in these logging displays, you can type git log, which will show a much longer kind of log. I'm just using this git log one-line shortcut I have. But this log shows you commit hashes, which we'll talk about in a second. And it also shows you if it's been tagged, it will show you the name. So you'll know that, oh, Nate tagged this version as v2.1.1 on a certain time. Which can be handy if you're working on a project with other people, or if you just want to track a version or publish a version of something. So let's talk about hashes. Each time you make a commit, Git stores a SHA-1 hash. You don't need to know the details. It's just that becomes a unique identifier for that thing. So the reason that's useful is, let's go into our bioread and then say git log -- one line, which will give you a view kind of like what I was doing. I've got pager on by default. I should have gone back to the default Git configuration. Yours might not be paged and it might just dump out a whole bunch. That's fine. You can pipe it to less to get the same effect. Once you've got this log, let's look at this log, and we've got all these hashes over here. I'm curious, what's changed since this version change? What's all this stuff? What actually changed in this Git repository? So let's say we're interested in this before A2 revision and do git diff before A2. So let me back up and leave that on screen for you to see for a second. Diff is Git's way of saying, I want to see the difference between something and something else. By default, if you only supply one thing, it compares that thing to what the latest version is. So git diff blah. And you don't have to type the whole hash as long as what you type is unique. Git will be smart. And then by default, this will just sort of show you a whole bunch of changes that have happened in a particular diff format. By default, it uses this minus to mean a line was removed and a plus to mean a line was added. So we can see that this line was removed and added really just to change this capitalization. Yeah, one branch is normal, Nate. I'm not worried. I wasn't looking for a complicated example. The other thing we can do though is if we go back to our log, since we've got these tags, we can use these tags to say what's been different, what's been changed since a specific version. So we can say git diff a specific version, and we can also say give git 2 revisions with a ... between them, and it will tell us what changed between those two things. So if I look at my log here, if I want to see what changed between version 2.1 and version 2.0, like what exactly changed in these commits, all I have to do is do git diff, and I'm going to cheat and copy and paste this so I don't get it wrong, like that. So we're saying git diff from version 2.0.0 to version 2.1.0, and this will let you see what exactly was changing. You can also specify, excuse me, specific files if you want to see what changed in a particular file. That's also sometimes pretty useful. All right. Any questions so far?
Do you need to write the file names, just one file name, or how do you do it?
If you want to see,
you're comparing between two versions.
If you want to see the diff of a particular file, you need to do, let me go back to my prompt. Let's say we want to see, I don't remember what the files were. You would add a, I'm I'm having some terminal lag here. That's fun. You would add a, excuse me, a dash, oh geez. You'd add a burp, burp, dash dash and then the file name, I believe. And that would limit the diff to just that one file name. Does that answer the question?
It does.
I don't think you need the
thanks.
dash dash.
You don't even need the dash dash?
I think not.
Awesome. They've simplified a lot of stuff over the years, and some of my Git patterns are kind of old. This is an updated version of a presentation from 6 years ago.
Yeah, one of the things that's weird about Git is there's a lot of outdated stuff on the internet that works, but is really weird compared to how you would do Git stuff now.
Yeah, they've really simplified things. Some other words that you might hear tossed around in the Git world is a remote. So a Git repository can have many different versions all over the place, right? So we've got just a copy of this BioRead repository. There's one that's on GitHub that's like the central one, but Nate also has one that he's been working on, and so now we've all got copies of the same repository. But we all have that central GitHub one as the remote, so that we pulled from that remote. If Nate was to send changes and commit them and push them to BioRead, we could all pull those changes from that remote. And theoretically, depending on your workflow, that's as simple as typing git pull. And sometimes it gets a little funky. If you've made changes and the other person made changes, if you pull the other person's changes and they collide, Git will warn you and say, oh, you've got a conflict you've got to resolve before I'm able to merge that in. A lot of times, Git is smart enough that if the changes don't conflict, you will just get an automatic rebase and their changes will get merged in with yours, which is magical and amazing for anybody who lived in the times before Git. A lot of times GitHub is the central host, but that's not necessarily a requirement. We've got a location on the study drive servers for kind of our internal tools that we push and pull to when we have stuff that we don't want to send to GitHub. Maybe we're embarrassed about MATLAB code, I don't know. Another thing that's happening in the...
Sorry, one more thing, Dan. Could you expand a little on the rebase? Because I've seen the terminology and I'm not entirely sure what that...
Yes. So a rebase is when you have a branch with changes and somebody else has a branch with simultaneous changes, and you want to take those changes and apply them on top of your branch. There's a couple different ways to rebase. Yeah, like Nate says, nobody 100% understands everything you can do with rebasing. You can do things like on your existing branch, you can rebase to collapse your changes into a single change and then pull their changes on top of that. You can use rebase to apply their changes first as if they had been applied first and then reapply your changes. There's a lot of different options that Git provides. By default, though, what's going to happen is your changes will happen. You'll pull from the branch to do a rebase, and it will do a merge commit on top, and it will attempt to just make your branch be a rebased version of the two sets of changes.
So this is assuming that there's no conflicts?
Yes, if there are no conflicts.
Right.
And Git is a lot more careful about conflicts than other version control systems were in the past. It will look at specifically where in the files there are changes. So if a file has been changed at the top by you and at the bottom by them, it will merge just fine. It will detect no collision.
Couldn't that cause problems though? I mean, in terms of code sequence, if something is expected and
yes,
the other person's doing something which changes what's supposed to happen?
Yes, that's why you'll want to read their commit messages and hopefully have some tests. It's still always a good idea to be communicating with people if you're editing the same files. Right, and if conflicts happen and weird stuff gets weird, don't freak out. It happens to everybody. I'll actually send a link in the email chain after this meeting with this recording and the slides and this handy site that's called Oh Shit Git, which covers a bunch of scenarios you can get yourself in where you're like, oh crap, how do I get myself out of this? There's a lot of pretty easy ways to get back to where you were. The other thing,
there's a dang it Git as well, which is the same thing, I believe.
But with less swearing, right?
Yeah, exactly.
The other thing that's been happening is software developers have realized that a lot of our terminology, like white and black lists and master branches, is based in racist terminology. By default, Git still names things when you make a repository. It names the main branch master, and that's just the way it's been since Git was developed. I have a feeling that eventually that may change. GitHub is already encouraging people to rename your master branch to main with just the simple command that you can paste in. And all this does is it says, hey, take my existing branch named master and call it main. So that's a command you might see. It's super easy to do. It's a little funkier if you're running an existing project and multiple people have, oh, there's a nice command from Nate to make it just config everything that way by default. I will steal that and put it in my config later. This presentation does not cover configuring Git, but there's a lot of things you can tweak in your config file, and you can make certain things default. You can make aliases for commands. It's all extremely powerful, and we're not going to cover all of that in 30 minutes. The other thing I do want to talk about, though, is there are various clients other than the command line. So what we've been seeing so far is you're just typing in commands. If you're me, I love typing in commands, and that works really well for me. But some people would prefer to have a user interface into Git. There's a default one that comes with Git called Git K. And you'll see that this is basically the same information that was in that Git log that we looked at before, except now I can kind of click on things and I can easily navigate between diffs of things. If you're a more GUI person, there's options out there. There are good ones that are free, like Source Tree, and there's good ones that people pay money for, like Tower. I am not a Tower user, but I know lots of people who swear by it. Just it's good to know that there are options out there for clients.
RStudio also has Git support, so
yeah,
you can also
most IDEs actually do have their own built-in Git support these days, but it's fairly rudimentary. If you want to do fancy things, you might need another client. But if you're just making commits and pushing and pulling, you can probably stay with Visual Studio or what other IDEs are people using. I think there's even Git plugins for like Sublime Text and stuff. So I don't know. It's worth looking into if you have an editor that you'd like to integrate more tightly with Git. Now we've come to the part where I'm just going to talk real quick about things that you can do with Git that are relatively easy and good to know for the future, but we're not going to give examples of them just right now. Git blame will tell you who made changes to each line in a file. So you can say git blame a file name, and it'll tell you who most recently changed to that. It's got options so that you can also include the commit message alongside there, so you can see a little bit of context about, oh, why was this line changed? A command that I use all the time that is super handy is you can do git log -S, which is called the pickaxe for some reason in Gitland. What that does is if you put a word after git log -S, it will search all of your changes and all of your history for when that phrase or word or whatever was added or removed from files. So if you're like, oh man, I remember there was this stuff that dealt with a variable named Christmas tree, then you could git log -S Christmas tree, and it would find all the places where that variable had been referenced and maybe deleted even. So that's super handy.
Is it on the comments, or is it looking at the changes?
It's looking at the actual file content, the changes.
Oh, okay.
So you can also grep the comments, but I don't do that nearly as often. The other thing you can do that's really fast and easy is if you want to find something inside your current version of files, you can always do some kind of like ls xargs grep craziness, or you can just type git grep and then the name of the thing you're looking for. So you could do git, what's a good example of something in BioRead? Let's go with acknowledge. Nope, maybe not. Oh wait, because I'm spelling it wrong. It's ace.
ACQK.
If I can spell it right, there we go. And then we see that, oh, it's in test reader. He references, I think it's a bug in acknowledge. Fun. Anyway, that's a quick way to grep your tree. There's also really simple ways to compare branches or versions. I showed a little bit about that, but you can delve into that further if you need to, and we can help with that if you're ever curious. And then I didn't really talk about branching and merging in the context of this quick tutorial, but it's pretty easy in Git. Even though you can get really, really complicated, it's pretty easy to have a simple main branch and then branch off of it and back into it, so that you can have multiple people developing at the same time. The level 2 stuff, I talked a little bit about rebase, but there's also ways to, when you're pulling in changes, you can cherry pick parts of files. A hunk is a part of a file. So you can be very specific about what you're pulling in or committing even. You can commit just parts of a file instead of committing all of it. Rebase -i is, I still don't understand all the things you can do with it, but you can basically, if you haven't pushed your version of the repository to somewhere yet, you still always have the ability to change what you've been doing recently and make it look like you're a genius by changing out some commit comments or squashing multiple commits into one, or just saying, oh, that one commit, I didn't want that one to happen at all. I'll just get rid of that. Rebase -i will let you do that. A config trick I really like is having aliases for quick logs. The one I use most is the graph log. So I have that on LG, and what that looks like is, oops, if I can type, that's this thing where it shows you sort of the branching nature of your merges and branches. And it also does the really handy, instead of showing you a date, says something ago, which I greatly prefer. There's also things like pull requests with GitHub. We're not going to really touch on that now, but it's all optional. The thing you should take away is, if you're working on scripts on the study drive and you want a quick and easy way to track your changes, you can just git init in the directory with the scripts, and then you can git add dot if you want, or the specific scripts, and do commit, and just do the add and commit anytime you're working on things. If you leave and come back and you had changes pending, you can just type git status. What's happening? Git diff. What did I change but I didn't commit yet? Another one that's kind of handy to be able to do is if you've already added stuff and you're like, wait, what did I already change in this? Because by default, Git Diff will only show you the stuff that's different in your working copy. If you want to see what's different in your stage, you can do Git Diff -- staged. I use that one quite a bit as well. But then you would basically just be having these time points, and it would be very easy to pull up a Git UI or do a little Git log, and then find the version of an earlier file, or find an exact change that caused a problem or that you want to investigate. Yeah, any questions about the whirlwind tour?
Very helpful, thank you.
I'm going to shut off my screen sharing and stop recording before I forget.
I will give a